Welcome to this explainer. Today we're unpacking the invisible forces right above our heads, the ones that literally dictate human survival and power the mighty monsoons. I am so excited to guide you through this because, think about it. We walk around every single day completely submerged in this giant ocean of air, and yet we rarely stop to think about the incredible mechanics making our existence possible.
So let's kick things off with a crucial question straight from our source material to really set the stakes here. Can you imagine Earth with no atmosphere? I mean, without it, we'd have absolutely no shield from the sun's harmful ultraviolet radiation. There'd be nothing to trap the sun's heat, meaning our planet would be completely unable to regulate its temperature. Without this invisible blanket of gases held down by gravity, there are no clouds, there's no weather, and most importantly, no survival for living beings. It's literally our life support system.
All right, here is our roadmap for today. 1. Earth's invisible security blanket. 2. Layers of the atmosphere. 3. Decoding weather and climate. 4. Air pressure and winds. And finally, number 5, the mighty Indian monsoon.
Section 1. Earth's invisible security blanket. Let's dive in.
It's kind of wild just how dominant nitrogen and oxygen are, right? I mean, they make up a whopping 99% of the air we breathe. Oxygen is, of course, essential for us, while nitrogen is absolutely vital for plants. But think about that tiny sliver remaining. That final 1% contains argon, carbon dioxide, and a few other trace gases, along with water vapor and tiny dust particles. And here's the crazy part. Even though water vapor generally only ranges from 0.1 to 0.4% of the atmosphere, it plays a massive, totally disproportionate role in cloud formation and precipitation. Small, but mighty, for sure.
Okay, moving on to Section 2. Layers of the atmosphere. Let's take a quick trip up through these layers, starting from the ground up, where the air is the most dense. First up, the troposphere, stretching up to about 12 kilometers. This is our neighborhood. It's where we live and where nearly all our weather, rainfall, fog, all of that happens. Above that is the stratosphere, reaching up to 50 kilometers. It's super clear, free of clouds, making it the perfect cruising altitude for airplanes. And crucially, it holds the ozone layer, which acts like Earth's sunscreen against UV rays. Keep climbing and you hit the mesosphere, where most meteorites hurtling in from space actually burn up before they can hit us. Above 80 kilometers is the thermosphere, where temperatures just absolutely skyrocket. This layer actually helps bounce radio waves back to Earth. And finally, the exosphere, the very edge. The air here is incredibly thin, and light gases like helium and hydrogen just kind of float away into deep space.
And man, this brilliantly illustrates the magic of the thermosphere. What we're talking about here is the aurora. When charged particles, blasted out by the sun, which we call the solar wind, reach Earth, our magnetic field funnels them toward the poles. As these charged particles slam into the different gases in the thermosphere, it causes each gas to glow with a specific, vibrant color. We call this absolutely stunning, dawn-like light display the aurora borealis in the north and the aurora australis down in the south.
All right, Section 3, Decoding Weather and Climate.
So a really crucial point here is distinguishing between weather and climate, because people mix these up all the time. When you look out the window in the morning to decide if you need an umbrella or a jacket, you are checking the weather. It's the hour-to-hour and day-to-day condition of the atmosphere. It can change rapidly, like on a dime. Climate, on the other hand, is the sum total of those weather conditions and variations over a huge area for a very long extended period, usually 30 years or more. Think of it this way. Weather is your mood today, climate is your overall personality.
Let's roll into Section 4. Air pressure and winds.
You see, it all starts with temperature, and temperature is dictated by something called insolation. Insolation is just a fancy way of describing the incoming solar energy intercepted by the Earth. Because our planet is a sphere, sunlight strikes most directly right at the equator. As you move toward the poles, the angle of the sunlight becomes lower and more stretched out, meaning the amount of insolation really drops off. And that is exactly why the equator is scorching hot and the poles are freezing. Now, this varying temperature heavily influences our next crucial element, atmospheric pressure. This is literally just the heavy weight of the air pressing down on the Earth's surface. Now, you might be wondering, and honestly, it's a great question, if the air is so heavy, why aren't we just crushed flat by it? Well, it's a fascinating detail from our sources. Air presses on us from all sides, and our bodies actually exert a counterpressure from the inside out to match it, so we don't even feel it. Pretty cool, right? This contrast in pressure is literally the engine of our weather. When insulation heats up an area, the air gets warm and light, so it rises up like a hot air balloon. This creates an area of low pressure underneath, which is usually associated with cloudy, wet weather. Conversely, cold, heavy air sinks, creating high pressure, and that heavy sinking air brings us beautiful, clear, sunny skies.
And you know, nature always wants to balance things out. It absolutely hates inequality. So air is constantly rushing from those heavy, high-pressure areas over into the lighter, low-pressure areas. That movement of air, that is exactly what we call wind. It can be a gentle breeze rustling the dry leaves, or it can be a fierce storm uprooting trees. A great everyday example of this is the coastal sea breeze. Land heats up way faster than water during the day, creating low pressure over the land. So the high-pressure, cooler air from the sea rushes in right over the beach to fill the gap.
And that brings us to Section 5, the mighty Indian monsoon.
The word monsoon literally refers to a seasonal reversal in wind direction. It is the absolute ultimate showcase of those high and low pressure dynamics we just talked about, all driven by the unequal heating of land and sea. During the summer, the vast landmass of India heats up much, much faster than the surrounding Indian Ocean. This creates a massive low-pressure vacuum right over the subcontinent. So what happens? The cooler, high-pressure air sitting over the ocean rushes in to fill that giant vacuum, bringing with it immense amounts of moisture. These moist southwest summer winds are exactly what deliver the life-giving rains to the entire country.
Now, while modern meteorology typically tracks 4 seasons, winter, summer, the advancing monsoon, and the retreating monsoon, traditional Indian systems mapped these atmospheric shifts quite differently. The traditional calendar actually recognized 6 distinct seasons, known as ritus. This framework deeply tied the subtle changes in the climate directly to agriculture and cultural life, long before any modern weather instruments even existed.
And honestly, the historical ingenuity here is absolutely staggering. Because the entire crop cycle depended on these seasonal rains, ancient scholars developed brilliant methods for prediction. Krishi Parashara used the positions of the moon and sun. Varahamihira incredibly used 27 lunar mansions, or nakshatras, basically dividing the sky into 27 equal parts along the moon's path, to predict seasonal rainfall. And poets like Kalidasa, writing way back in the 5th century CE, were accurately documenting the onset dates and tracing the very paths of monsoon clouds over central India. Even today, a lot of traditional farming practices still consult these ancient sky-watching methods. Today, the Indian government actually carries on this immense predictive legacy through the National Monsoon Mission. Utilizing state-of-the-art climate models, the Ministry of Earth Sciences works tirelessly to forecast these seasonal reversals. And it matters. It matters deeply. These predictions dictate water supply in reservoirs, the sowing of crops, the risk of floods or droughts, and ultimately, the survival of the entire agricultural economy and millions upon millions of lives. So, to wrap up this explainer, I want to leave you with a final thought and a bit of a challenge. When you step outside today, take a deep breath. Feel the temperature on your skin, watch the clouds move, and realize you are standing at the bottom of an invisible ocean of air, governed by massive churning forces. What invisible mechanics are shaping the weather right in your own backyard today? Thanks for exploring with me. Keep looking up and stay curious.